Hey there again, APers. This is Mrs. Coleman to talk a little bit more about electrochemistry. Remember in our last podcast we talked about how electrochemistry was the study of the movement of electrons through a reaction. And basically what we have there is a redox reaction. Redox reactions have two parts. An oxidation reaction, where the species is losing electrons, and a reduction reaction where the species is gaining electrons. Now we can perform redox reactions in electrochemical cells where we separate the half reactions for the oxidation and reduction. And oxidation is going to occur at the anode, where our reduction reaction is going to take place in the cathode. Now, there are two types of electrochemical cells. The last podcast talked about galvanic or voltaic cells. These type of cells are going to separate the oxidation and reduction reactions so that we generate an electrical charge. The other type of electrochemical cell that we'll talk about now is the electrolytic cell. This type of electrochemical cell requires a charge. So if we take a look at the electrolytic cell, we still have the cathode and the anode, and this time we have a power source. And the power source could be a battery, or we could plug it into like an outlet, for example. And the flow of electrons is going to come from the power source into the cathode, and then the electrons will be lost by the anode. And so over time, what happens is the anode is going to reduce its mass, and the cathode is going to increase its mass. Now, electrolytic cells are really, really useful because what we can actually do is reverse the process of our galvanic cell. Now, remember, batteries are basic galvanic cells, and so we can use this electrolytic process to recharge our batteries. We can also use this electrolytic process to plate different metals, like a protective coating, and we use electrolysis to actually create pure metals like copper or aluminum. So let's take a look at what kinds of things we can do with these electrolytic cells. So for example, let's say I wanted to figure out how much copper I could make when a current of 10 amps or amperes is passed for 30 minutes through a solution containing copper 2 ions. So over at the top left-hand corner, you can see a diagram of what's happening here. The important half reaction that we're looking at is copper ions gaining 2 electrons and creating those copper atoms as a solid. So this is how we're going to do this. We're going to kind of follow a flow chart to help us to understand how to do this. The first thing we do is understand what we know. Right now we know the current and the time. It was given to us in the problem. And we can actually use the current and the time to figure out the quantity of the charge in coulombs. And in order to do that, we need an equation. This equation is going to be given to you on the AP exam as one of your, on that sheet of reactions, or excuse me, equations and standards. So the I stands for the current in amperes, the Q stands for the charge in coulombs, and T stands for time in seconds. So if we know current and time, we can work backwards to solve for Q. Once we've solved for Q, we can actually convert that into moles of electrons. We can do that using Faraday's constant, which I'll talk about in just a little bit. And once we know how many moles of electrons we have, we can use the balanced half reaction stoichiometry to figure out the moles of copper. And then, of course, moles of copper can easily be converted into grams of copper. So let's actually do the math. Let's try it out. So remember, on the left-hand side, we've got our action plan. We have our given information, which is our current and our time. Amperes, remember, guys, is just coulombs per second, so I've just changed the unit there. We're going to use our equation. I'm going to rearrange the equation so that we can see, so we can actually solve for the current. Now, my current is 1.8 times 10 to the negative 4th coulombs, and so I can actually then convert that into moles of electrons using Faraday's constant. Faraday's constant is, again, one of those given values on the AP exam, and it tells us that for every 1 mole of electrons, we have 96,485 coulombs. And so we can use that to just convert units. So I can take my coulombs and convert it to moles of electrons. Once I have my moles of electrons, I can look at the mole ratios in my balanced half reaction, and I can see that for every 1 mole of copper, I need 2 moles of electrons. So I'm going to divide the moles of electrons by 2, and that gives me the moles of copper. and then simply multiply by the grams of copper, the molecular mass of copper, to solve for grams of copper. So at 10 amps for 30 minutes, I can create 5.98 grams of copper. Now, you could also do a similar process, but in reverse. What if I wanted to solve for time required to produce a certain amount of metal at a given current? So I'm trying to make a certain amount of copper, and I need to know how long I should run the current for. You're going to do this basic process again. So this time you know how many grams that you want. You can convert grams into moles. You can then convert moles into moles of electrons. You can use Faraday's constant to convert moles of electrons into the charge. And then remember, you're given the current as part of the problem, so you can then go to and solve for T in our equation. I hope you found this helpful. Stay tuned for one more Electrochem podcast about the Gibbs free energy and electrochemistry.